Here's another example for a t-interval for a population mean. As part of their final project in AP Statistics, Christina and Rachel randomly selected 18 rolls of a generic brand of toilet paper to measure how well this brand could absorb water. To do this, they poured a 1/4 cup water onto a hard surface and counted how many squares of toilet paper it took to completely absorb the water. Here are the results from their 18 rolls. Construct and interpret a 99% confidence interval for mu, the mean number of squares of generic toilet paper needed to absorb 1/4 cup of water. So let's think about what we want to do. So our goal. What's our goal? We want to estimate the mean number of squares of this generic brand of toilet paper needed to absorb 1/4 cup water. Okay, so that's what we're trying to find out, and this would be the mean for the entire population. Okay, so what are we going to do here, or what are our conditions here? What do we want to make? We want to make a 99% confidence interval. And we're going to say let's a 99% confidence t-interval for the mean. That's what we want to do. Okay, now let's look at the conditions. Number one, we have a random sample of 18 rolls of toilet paper. Okay, so that's given. That's right up there, randomly selected. Okay, number two, we know that 18 is less than 10% of all TP rolls of this brand. Number three, we don't know anything about the original population shape, and 18 is less than 30, so we have to make a graph of this. So I'm going to go to my calculator. I already have this data in a list here, so let me go back to, there's my list. So I'm going to go ahead and make a data and statistics page and do my TP here, and I see that this graph that looks kind of like this. I'm going to copy it, I know, and then I'll go ahead and make a sketch of it too, just to show you what we're looking for when we do this. Okay, so what I would do is just make a little dot plot and make the dots. 1, 1, 2, 1, 1, 1, 2, 3, 1, 2, 3, 1, 1, 2, 1, 1, 2, 3. So looking at this dot plot, I would say the distribution of square numbers or the distribution of data, we'll just say here, has no obvious skew or extreme outliers. So we can use a t-model. Basically what we're saying is it's plausible. Maybe I ought to go ahead and write that down. So it's plausible that the population is close enough to normal to use a t-model for the interval. Basically, I'm looking for something to stop me, not for something to totally convince me. Okay, so I'm going to get rid of that now. Okay, so I've checked my conditions. Now I'm going to make the interval. So let's do it kind of the way now that you're probably going to do most of the time. Let's go ahead and do it on the calculator first and then fill in the values. So once again, I've put this data already on my calculator, so I'm going to open up a calculator page and I'm going to do my statistics, confidence intervals, a t-interval, and I'm going to use my data. And so I have my data as my TP roles here. I wanted to do 99% confidence interval, I believe. Let me double check that I want to do a 99 one. I'm pretty sure that's what I wanted. Let's see. Yep, I wanted a 99 confidence interval. So, okay. And I'm going to copy this and put it into my file here. Now you'll be able to just look at your calculator, but I want to show you what I'm going to do with these numbers now. Okay, so I've got important numbers that I need for my interval. So I'm going to put in my x bar. So there's my x bar right there that I need. 24.9444 plus or minus. And my t critical value I'm going to leave a spot for because I don't have that yet. But I'm going to put in my sample standard deviation, 2.85888 divided by the square root of my sample size, which is 18. Now I need to have the t critical value for 99% confidence interval for 17 degrees of freedom. So t sub 17 at a 99% confidence. I can do that on the chart. So we can do that on a chart, but let's just remind you how to do it on the calculator because we haven't done that for a while. So on the calculator, I would do menu, statistics, distributions, inverse t, number 6, put in the area under the curve for 99% confidence interval would be 0.995. Remember, you have to add that little tail at the side and the left. Degree of freedom was 17. That's one less than the sample size. And there's my number, 2.898. That's sufficient. 2.898. Now let's just double check on the chart just to show you that you could get the same number from the chart. So, okay, oops. So if we go to 99% confidence interval here, go up to 17 degrees of freedom, there's the 2.898. Okay, so same number that we had. Oh, going a little farther past where I wanted to go. Okay, so I'm going to substitute that in, 2.898. And then I'm just going to write down my confidence interval, 22.9915, comma, and I forgot to do this on my last example. This is how you write the confidence interval once you have it, 26.8974. You just put smaller number, comma, larger number, and you just write it like that. Just like we did interval. It's basically interval notation is what it is. Okay, so my conclusion, I think I'm just wanting to estimate here. Okay, construct and interpret a 99% confidence interval. So yes. So my conclusion here, I am 99% confident that the interval from 22.99 to 26.897 captures the true mean number of squares of generic toilet paper needed to absorb 1/4 cup of water. Now about now you're probably thinking, as you finish writing, that man, we have to write a lot of repetitious stuff. And yeah, there is some repetition to this, but I want you to think about the fact that you have to communicate very clearly, and to communicate very clearly means showing that you totally understand what these numbers mean. So you have to be very specific in the way you talk about them. I'm not asking you to write long essays. I'm ask to write a few detailed sentences and paragraphs. That's what you're going to have to write. But just recognize that you're going to have to do that. Okay, one last thing we need to talk about with confidence with the t-intervals is how do you find the sample size you need for a particular margin of error. So that'll be the next video, and that'll be our last topic for this unit actually.